Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Dear students, today we will end this chapter now, inshallah. It is the last lecture of this chapter. We have small three topics there. The first one is refraction by a concave lens. Earlier we have already done refraction by a convex lens. Now today we have to discuss refraction by a concave lens. There is only one case. Let me discuss that case here. It is, let me draw a concave lens. This is optical center. This is principal axis. Okay. This is virtual focus. This is double focus. Again virtual focus and double focus. Let me keep object here. Now I have to see where will be the image formed. The light ray which is parallel to principal axis must pass through focus. जाती तो लाइट रे यहां से है, लेकिन यहां से हम देखते हैं कि अगर इसको हम प्रोड्यूस करें तो ये गुजर जाती कहां से? फोकस में से. This is concave lens. इसमें ये वर्चुअली होता है. The light ray which passes through optical center retrieves its path, does not change its path. वही से चली जाती है. यहां हो गए ये इंटरसेक्ट. So यहां बन जाएगी इमेज. Look. The image is formed in front of object. Image is formed in front of object. It is a virtual image. Dotted. Virtual means it cannot be taken to screen. It cannot be stored in a storage device. You cannot store it in a hard disk, in a pen drive. That's not possible with it. It is smaller in size. If you check the size of image, it is smaller than the object. It is an erect image. It is erect. It is not upside down. It is not inverted. It is erect. This is the only case discussed in case of concave lenses. So remember, when object is placed in front of a concave lens, the image is formed in front of object. It is a virtual image. It is an erect image and the image size is smaller than the object. So I have drawn the diagram. You can check it in diagram now how image is formed when the object is placed in front of a concave lens. So this is done. Next topic. Next, that is magnification by lens. Magnification. This topic tells us when image is formed by a lens, the size of image may be bigger than the size of object. It may be smaller than the object, or it may be equal to the size of object. This topic is about the size of the image and size of the object. It tells us how bigger is the object or how smaller is the object. It tells us how bigger is the image or how smaller is the image than the object. It compares the size of the image with the size of the object and tells us whether the image formed is enlarged, diminished or normal. This magnification is represented by small n. And small n is calculated by taking the ratio of height of image upon height of object. H2 upon H1. H2 image height. H1 object height. If we take the ratio of height of image and height of object, we will get the value of m. The value of m can be greater than 1. The value of m can be greater than 1, which depicts image is greater than object. Size of image is greater than size of object. The value of m can be less than 1, which depicts size of image is less than or smaller than size of object. This m can be equal to 1, which means size of object and image is equal. Please remember, we have to take the ratio of h2 and h1. If we get the value greater than 1, that means image is bigger than the object. If we get the value of m less than 1, which means object is bigger than the image. And if m equals to 1, that means size of object and size of image is same. We can also calculate it. The value of m can be calculated by taking the ratio of image distance and object distance. It can be done. We can calculate the value of by taking the ratio of height of image and height of object. We can calculate the ratio of m by taking the ratio of image distance and object distance. V, it is image distance, and U, it is object distance. Now by combining this one with this, we can say h2 upon h1 equal to v upon u. This formula is used to solve numerical problems. We can solve numerical problems by using the formula h2 upon h1 is always equal to v upon u. We can do it. h2 upon h1 equals to v upon u. This formula is usually used to solve numerical problems. If we know the value of 3 of the variables, the fourth one can be calculated. If we have the value of h2, h1 and v, we can calculate the value of u. If we have the values of h2, h1 and u, we can calculate the value of v. Similarly, if we have the values of h2, v and u, we can calculate h1. And if we have the values of h1, v and u, we can calculate the value of h2. This is magnification. Next more topic, that is the last topic of this chapter, that is power of lens. Power of lens. Power of lens, it means how easily a lens converges or diverges the light rays passing through it. Power of lens means how easily a lens converges or diverges the light rays passing through it. If it is a convex lens, then it converts light rays passing through it. How easily it converts, that will be its power. If it's a concave lens, it has to diverge light rays passing through it. How easily it diverges, that will be its power. I'll give an example here. It's a convex lens. Okay. This is optical center here. These are light rays passing through it. Let them intersect here. Point F. Let the distance from this O to F is 5 centimeter. There is one more lens. This is one more lens. So optical center. Let these are light rays. This is F. This lens converts light rays at a point F, which is 5 centimeter away from optical center. This lens also converts light rays at f, which is 10 centimeter away from optical center. We can say, since this lens converts light rays more easily than this one, the distance from f to o is only 5 centimeters. That means it has easily converged them or easily intersected them. And this one, the light rays have covered a good distance, then they have intersected with each other. We say the power of this lens is more compared to this lens. More powerful lens. Powerful lens. When these two are compared, this one has more power, this one is less in power than this one. So we define power of lens. Power of lens, it is the reciprocal of focal length. More the focal length, less is power. Less the focal length, more will be the power. This focal length from O to F is focal length. As the value of this OF increases, that means power of the lens is decreasing. And if the value between O and F decreases, the power of lens is increasing. So P is 1 upon F, power of a lens. It is the reciprocal of focal length. It is reciprocal. Reciprocal of focal length. Okay, we measure power in diopters. It's SI unit. That is diopter, represented by capital D. The power of lens is measured in diopters. Okay, 1 diopter power. I'll write it first. One diopter power. If a lens has a focal length of 1 meter, its power is 1 diopter. 1 diopter. If focal length of a lens is 1 meter, its power is 1 diopter. If focal length of a lens is how much? 1 meter. So if F equals to 1 meter, P will be equal to 1 diopter. With this chapter comes to an end. इसके सारे टॉपिक्स हो गए. Stay blessed. Fi amanillah. Assalamu alaikum wa rahmatullah.